square.
Still working in standard 8 in the geometry unit. We're still using that Pythagorean theorem of a squared plus b squared equals c squared, but we're going to move on to learning target 3, which is you can still use that Pythagorean theorem, but now we're going to put them into real-world problems because honestly, the Pythagorean theorem is used in many real-world situations, such as building a house or constructing a building. So you in your future will probably at some point use the Pythagorean theorem. So we're just going to look at some real world problems. It might not be one that you actually ever use, but they are actual storylines that could use the Pythagorean theorem. So our first one is going to be, I'm going to read it. Campbell wants to get a computer monitor to hook up his PlayStation 2. His gaming desk can support a 22-inch monitor. He has found a monitor that's 16 inches wide and 10 inches tall. Will the computer fit on Campbell's gaming desk? So first of all, just some background information. So this is one way to use the Pythagorean theorem is the idea of buying TVs. And if you have a certain spot or certain place where this TV has to fit in, TVs are, so if we look at a TV here, TVs are measured on its diagonal. Okay, so you will probably measure its height and the width, but when you go into a store and you look at the box and it says it's a 50-inch TV, it's actually a diagonal 50-inch. And that's kind of for some people, that 50 inches, of course, that hypotenuse is going to be longer. So it's not the 50 inches wide, which is a lot of people think. It's that 50 inches in the diagonal. Personally, I think they do it that way because it makes it sound like it's a bigger TV. Because if you do the diagonal, we know that's the longest side. And so it advertises 50 inches, which is longer than 50 inches wide. Okay, so we're going to look at this. We'll say that's his gaming or his monitor. We're going to give him a desk here. And Campbell's desk can only support a TV that's 22 inches. So the question is, can the TV that he's looking at support that 22 inch? So we're going to use the Pythagorean theorem. And when I read this, it says it's 16 inches wide. So we'll say this is 16 inches, and this is the 10 inches tall. And this is where our 90-degree angle will be. So I can see my 90-degree angle formed. So I'm going to apply the Pythagorean theorem. So we have 16 as a leg and 10 as a leg. So I'm going to place that in for my A and my B. So square the 10, which is 100. Square the 16, which is 256. And I'm just going to leave C squared by itself. So at the end here, we can determine if it can fit 22 inches. And then we're going to add these together. So 100 plus 256 is 356 square. And then remember how to inverse the square. We're going to take the square root of 356, which is C. And I'm going to put that in my calculator. And that is approximately 18.9 inches. So looking back at this station, the one that he's looking at, Campbell's looking at this monitor that's 16 inches wide and 10 inches tall, and his gaming desk can support a 22-inch. Well, then this 18, almost 19-inch TV here will be able to be supported. So the last thing when you do storylines is just to write a sentence that explains your final answer. So since it asks the question, will the computer fit on Campbell's gaming desk? My answer is going to be yes. The monitor he found will be supported on his gaming desk. So that sentence you're right. There's nothing in particular that you have to write. You just need to answer the question that was put in front of you. So because it's less than 22, it can be supported. Let's look at the next problem. It says a painter has to paint a wall that's 3 meters high. The painter has to put a base of the ladder 2 meters away from the wall to ensure it won't tip. What will be the length of the ladder required by the painter to complete his work? So first of all, I am always sketching my storyline out. I am a visual learner, so it makes a lot more sense to me when I see the picture. So we'll pretend this is my wall. I'm going to label this as 3 meters. And I know I have to have a ladder. So I'll make this our ladder here. Okay. I know that's my unknown. I don't know how tall, because that's what it says. What will the length of the ladder that needs to be required? But I do know that this, from the base of the ladder to the wall, is 2 meters. So when I draw it, I can see that right triangle right here. And I notice this is a leg for the height of the wall. I notice this is a leg. The distance away from the wall is the ladder. So I know I'm looking for my hypotenuse. So now I can start with using the Pythagorean theorem. So a squared plus b squared equals c squared. We'll say 2 squared plus 3 squared equals c squared. 2 squared is 4. 3 squared is 9. Woo. Okay. And 4 plus 9 is 13. And to get rid of that square, so we can just find the length of that ladder needs to be, we're going to take the square root of 13. We're going to round it to the nearest tenth. So when I put it in my calculator, it's approximately 3.6 meters tall. So going back to my question, now that I'm done, it says, what will the length of the ladder required by the painter? So a sentence could be such as, the length of the ladder needed will be at least 3.6 meters long. And you can, that sentence, it doesn't truly matter to me. It just answer the question that's there. One thing I was going to point out, when you're looking for the hypotenuse, one thing, because I know some of you sometimes solve for the wrong one, just remember that hypotenuse has to be the longest length. So when I put that 3.6 on there, that's a good sign because it's the longest length. So remember when you're solving problems that the hypotenuse has to be that longest length. Last one we're going to look at. So we have a sailboat. It has a large sail in the shape of a right triangle. Well, that's pretty easy. I can just make I'll erase that, try that again. We're going to make a right triangle here. Here is my right triangle. It says that the longest edge of the sail, which I just talked about, has to be my hypotenuse, is 17 yards. And the bottom edge of the sail is 8 yards. And it wants to know how tall the sail is. So good sign. I have this unknown leg here, and it looks like a height. So this is what I'm going to be looking for. We'll call that A. So now that I got set up and I'm drawn and I can see it, I'm going to go a squared plus b squared equals c squared. My unknown is a squared plus, remember, my b is one of my legs. That's going to be 8 squared, and that equals 17 squared. So 8 squared is 64. 17 squared is 289. Put my a squared, my unknown there. And since I'm missing a leg, we have to subtract because we want a squared by itself. So we get a squared equals the value of 225. I'm going to take the square root of 225 to get rid of that square, and that is 15. So a sentence could just be very simple. I'm going to put it sideways here because I'm running out of room. The sail is 15 yards tall. And that answered my question. So hopefully this helped you, and have a wonderful day.